This is lesson 1.03, measuring segments and angles. I'm going to kind of skip over some of these just to make the video a little bit shorter. So skills needed for this lesson, if you refer back to 1.01, we talked about complementary angles, two angles adding to 90. Supplementary angles are angles that add up to 180. Adjacent angles are angles that are next to each other, and a linear pair is two angles that form a straight angle, and they are also adjacent, and they are supplementary. So in here, find the measure of A, X, Z. These two angles form a straight angle, and so therefore 180 degrees minus 30 will give you this missing piece here, which is 150. Skill review 2, find the measure of angle BAC. These two angles here form a box, which is 90 degrees. And so 90 minus 50 will give you this piece here, which is 40. Skill review 3, select a pair of adjacent angles. Remember, adjacent means next to. And so if we look at our options, we have LKM and PKO. Those angles are not next to each other, and they're not vertical either. So we'll just skip over those. We have LKM and MKN. They share the side MK, and so those are adjacent. Skill review number 4, select a linear pair, so they have to form a straight line when put together. So PKO and MKN, those two are vertical angles. They do not form a linear pair. PKO and NKO, that's this angle here and this one here. Together they form a straight line on PN. So that's our linear pair. All right, moving on to our words to know. We have a couple here. Segment bisector is a point or a line segment that divides a segment into two congruent parts. So bisect means to split it in half. It creates two equal pieces. So let's pretend this whole segment AB was 10. This bisector cuts it in half. So this half is 5 and this half is 5. A segment addition postulate just means that if I were to add these two pieces back together, that would give me the whole segment. So AB plus BC would give me the entire thing AC. Angle bisector, same thing, splits an angle in half. If this entire angle measure was 30 degrees, the bisector would split it into 15 and 15. Angle addition postulate states that if I take those two pieces of the angle and put them together, it equals the whole thing. So ADC added to BDC gives me the entire angle ADC. Linear pair postulate states that if two angles make a linear pair, they are supplementary. That's part of our definition. So if this angle DAB is 125 and BAC is 55, together they add to 180, making them supplementary. Looking at some segment addition postulate questions. So before the postulate is introduced, the meaning of the word between in geometry needs to be discussed. So B is between A and C. As long as B is anywhere on the segment AC, it can be considered to be between the endpoints. If A, B, and C are collinear and B is between A and C, then we can break up our segment into two pieces that equal the whole. So AB added to BC, if you were to take these two pieces, add them together, it equals the entire thing AC. All right, there's a couple examples here for you to look through if you would like. I'm going to jump down here to save us some time. So guided example 1, state the known values. Name the segments from left to right. So something is equal to 15. 15 is the entire length. That would be RU. Make sure to capitalize. SU, segment SU, its length is 11. And then what is equal to 12? That is RT. And we are going to use these numbers further down here. So now, anytime I say that RU is equal to 15, wherever I have RU, I can substitute 15 in. and vice versa for all the other ones. So we are finding the length of RS. We know that RS plus SU, so RS plus SU is equal to the entire thing RU. We know RU is 15, and we know SU is 11. So we can substitute that into our segment addition postulate. So SU becomes 11, RU becomes 15. And then how do we undo something that is added to both sides? We go ahead and subtract it. So RS plus 11, we're going to take and subtract it from both sides. 15 minus 11 is 4. RT, we know is 12 up here. TU, we don't know yet, but we know RU is 15. And so similarly, this 12 is added. So we can subtract it from 15 to find the length of TU, which is 3. Then find ST. So write the segment addition postulate. From left to right, we have RS, ST, and then TU. So each of the different pieces of the segment equal RU, which is the whole thing. Using our segment addition postulate, we are going to substitute in the known values. So we know RS from up here is 4. ST, we don't know. We're finding that. TU from up here is 3. And we know from the beginning that RU is 15. So combine your like terms. 4 plus 3 makes 7. Subtract 7 from both sides to find our missing segment. 15 minus 7 is 8. Guided example 2. So state the known values. Let's name the segments from left to right. What is equal to the 14? That would be SU. What is equal to the 4? That is TU. And then 5 is TV. And then we're going to substitute our known values in to find the measure of UV. So TU, we know up here is 4, plus UV is equal to TV, which is 5. To solve for UV, we'll subtract 4 from both sides. 5 minus 4 is 1. To find ST, we can use the segment addition postulate. ST plus TU equals SU. We don't know ST, we know TU from up here is 4. And SU was 14. 14 minus the 4 gives us 10 as ST. In set notation, this just means union. And so we have, if we scroll back up, we have ST or TU or UV equal to the entire segment. Using our segment addition postulate from up here, we can now substitute these things in. So ST we found up here is 10. TU, if we scroll back up to here, was 4. And UV, if we go back up to here, was 1. So 10 plus 4 plus 1 is equal to 15. Similar concept with the angle addition postulate. Again, putting the two pieces together gives us the whole angle. So angle addition set notation follows the same pattern. Again, there are some examples for you to look at. In this one, the measure of angle FAB, so this piece right here, that's the blue and the purple. Find that measure if the blue FAE is 46 degrees and the purple EAB is 28. So we're going to write the angle addition postulate first. So the measure of angle FAE, this piece, plus EAB equals the whole thing FAB. Then we're going to substitute our known values in here. So the problem gives us that FAE is 46 degrees and EAB is 28. So substitute those in. Added together, so 46 plus 28 is going to give us 74 degrees as the whole angle FAB. Guided example 2. So if measure of angle CAD, this little guy right here marked in the blue, find that measure if BAC is 54 and EAB is 92. Together, these three angles form a straight line, which means that they're going to have to add up to 180. Write the angle addition postulate from left to right. So the measure of angle EAB plus the measure of angle BAC plus CAD is equal to EAD, the entire straight line. Then we're going to substitute the values in from up here. So we know EAB is 92. We know that BAC is 54. And a straight line is 180. Combine your like terms, 92 and 54 make 146. And then subtract 146 from 180, and you get 34. Getting into bisectors, angle bisectors. So again, it splits it in half. They're marked, segment bisectors are marked with little hash marks, 1 hash mark and 2 hash marks. These are not equal because they have different marks. 3 and 3 means that they are equal segments. So a segment bisector cuts a line into 2 congruent parts and passes through the midpoint. The midpoint on a line divides it into 2 congruent segments. So B is the midpoint of AC. We know that AB is equal to BC. We also know that AB is half the length of the whole segment. We also know that BC is half the length of the whole segment. So again, a bisector cuts it in half. So AB is half the whole, BC is half the whole. The whole thing is twice one of the halves. So that's what all of those mean. Angle bisector, same concept. With the marks, 1 arc is different from 2 arcs, so those have 2 different measures, whereas 1 mark and 1 mark, 1 hash mark, means that they are the equals are angle and they have the same measure. Angle bisector, again, cuts the angle in half, so BD here, ray BD, is the angle bisector of ABC. And so these 2 pieces are equal. So let's say it cuts it in half. This side's 30, this side's 30. The whole angle is 60, which is not realistic because this is an obtuse angle, but still. Couple of different examples for you to look at. We're going to jump down to guided example 1. So QP, segment QP, is 11. That's from here to here. And then VS is 14. That's the whole thing. Find PS. So QT, line QT, bisects segment VF, creating 2 congruent segments, VP and PS. So PS is going to be half, so you're going to type in your fractions in 1/2, half the length of VS, and since VS is 14, half of 14 is 7. For QT, we have VS bisects QT, creating 2 congruent segments, QP and PT. We know that QP up here is 11. So QT, the whole segment, is going to be twice the length of QP. And 2 times 11 is 22. For this one here, select all true statements. That's not here. The measure of ROS and angle SOT equals the entire angle ROT. That is true. That is angle addition. OQ bisects angle ROS. So OQ bisects angle ROS. They each have one hash mark, meaning they are congruent, so that is a bisector. OP bisects SOT. So OP bisects angle SOP. Notice that there is no hash mark on this smaller angle here, so they are not the same. That is not a bisector. Then we have measure of angle ROP, and SOT. Since there's this overlap here, it does not equal the full angle. It equals more than that. All right, so if measure of angle ROT, so we're using basically this first statement up here. If the measure of angle ROT and SOT is 54, what is the entire angle? So the whole angle ROT is 120, my bad. So we're gonna put ROT 120 here, and we know that SOT is 54. Using angle addition postulate, we will also go ahead and subtract 120 minus 54, which is going to give us 66. Find the measure of angle ROQ. If we go back up here, ROQ is going to be half of ROS. And since we know angle ROS is 66 from up here, half of 66 is 33. Moving on to the review questions, select all the statements that show angle addition postulate. So remember, you have to, the two pieces have to equal the whole. So FG and GI equal FI, that's fine. FG and HI, so notice that it skipped over this GH, so that is not true. FG, GH, and HI equal the full segment, and then FG or GH equal FI. It's missing this HI part. Review question 2, find GH. So we can say that we know that the whole thing, FI is 23. We can use our, what are we trying to find? GH. We can use our segment addition from up here. Sorry, my dogs have decided they want to argue right now. Okay, so using the whole thing, if we know that the whole thing is 23 and GI is 13, 23 minus 13 gives us 10 for this piece here. Doing the opposite, knowing that the whole thing is 23 and FH is 13, that means that HI is also 10. So we have 10, our missing piece, and then 10. So 10 plus 10 is 20. We have 20 plus GH has to equal 23. 23 minus 20 gives us 3 for this middle piece here. Select all the statements that show the angle addition. So ACB and BCE should equal ACE. That is correct. ACB plus ECD. ECD is equal to ACD. No, because it's missing this angle here. ACB, BCE, and ECD. Correct. BCE and ECD. No. And so we are finding angle DCE. We know that this piece is 90. We have a straight angle as ACD. So the whole thing has to be 180. We know that BCE is 90 because of this box right here. So we'll subtract that from 180. And then we know this piece is 72. So we'll subtract that. And we are left with 18 degrees. All three have to add up to 180. And that is it.